Very good evening, all of you. Welcome to the FDP program conducted by EICT IIT Kanpur on the data science. We will be starting soon, waiting for the other participant to join in. Hopefully, we will be starting by the 6:15. So don't worry. Just wait. Please wait 5 more minutes before starting the session. So letting other participants also join in. I request you all to join in with your proper name, the name which you have used while signing in for this course, and the same mail ID which you have used while signing in. There is no attendance link. Please keep this in mind. Uh, and the attendance is automated by the Zoom, and that is done based on your name and your email ID. So it's basically try to match the mail and the email ID. So please join in with proper name and the same mail ID. There is no attendance link here. Okay, the attendance is automated. So please join in with your proper name, what you have given by the registration. Okay, so the text matching will be done. Based on that, your attendance will be automatic allotted. So let us start the today's session. Okay. Uh, I hope my voice is clear to you all. Just give me a second, and my screen is also visible to you. And one important note: the meeting is recorded. You can get the meeting link directly from the site. And if you are facing any difficulty uh, while getting the meeting link, you can just uh, plot a message into the WhatsApp group. You will Priyanka ma'am will be helping you regarding that, how you can get the meeting recordings. Okay, so just put a message into the WhatsApp group if you are facing any difficulty while getting the recorded meeting links. Okay, so yesterday we have completed till this one. This one we have already done. We have also done the deconstruction of the machine learning, and we have done conceptual, yeah, traditional, yeah. We have done till the objective based machine learning. We have already completed till the objective based machine learning. Okay. Now, next, this is an example of the multiple axes, how multiple axes combined to define a algorithm in the machine learning. Like here there is an example of the model family, like the traditional or the deep learning models which we customize, the models which we customize. Then we have the supervised and unsupervised reinforcement. So for an example, the q learning is based on the q learning is based on the reinforcement learning. Q learning is the reinforcement learning algorithm which is based on the deep learning. Then the linear regression based, what we have, it's a part of the supervised learning, and it's the part of the traditional learning. So these are the axes in the uh, hyperplane of the machine learning. Okay, please be on time. Now this is another example of an LLM. You all are familiar with the GPT and the Gemini. Most of the time, 90% of us are using the LLM. So how GPT and Gemini is made? So what are the types of the machine learning axes are used for building the GPT or the Gemini? So look, basically when we talk about the LLMs, they have the encoder and decoder both the architecture. Some LLMs are built only based on the decoder architecture, some are based on the both encoder and the decoder architecture. So, but that's a totally different story. Here we will be comparing upon the based on the axis, machine learning axis, what we have discussed yesterday. So when we talk about the learning paradigm, the learning strategy, what we have used. So GPT is based on the self-supervised learning, and Gemini is also based on the self-supervised learning with the reinforcement learning with human feedback. So which is abbreviated as RLHF. Then when we talk about the amount of data that is provided while training the GPT or the Gemini, as you all know, it has been trained on the complete textual data that is available on the internet. So the amount of data, based on the amount of data, they are the multi-shot. Like we have the zero shot, one shot, few shot, and the multi-shot. So they are based on the multi-shot, as we have the abundant amount of data available. Apart from that, first, after training on the multi-shot learning, GPT is also trained on the few shot learning, which is also called in context learning. Like they have given an example of the poem, some poetry, and asked them based on some 2 to 3 poetry, they have asked them to form a new poetry, that type of a thing. So in the case of the Gemini, it is totally based on the multi-shot, either multi-shot text or the multi-shot images which contains the text. And here the GPT multi-shot with the few shot learning. Then when we talk about the learning strategy, how model is trained. So model is trained, first the basic training is done, then the fine tuning. We have applied they have applied the fine tuning on the model to enhance the output of both GPT and Gemini. Uh, in in advance with the GPT, the Gemini is also trained using the tool reinforcement learning. Tool reinforcement learning, which is a type of a reinforcement learning. Then, if you talk about the model family, so both are based on the transformer architecture, but GPT is based on the only decoder architecture. Okay, initially they have used both encoder and decoder, but at the time of the deployment, now GPT has only the decoder. I have initially told you that thing. While the Gemini is based on both encoder and decoder architecture. So both encoder and decoder are built on the transformer architecture. So it's a transformer architecture. We have the encoder, we have the decoder, we have the self-attention mechanism. So using the self-attention mechanism, they find out the relevant information from the textual data, and that is how they are trained, the main thing. But while the deployment, the encoder has been removed in the case of the GPT. It is based on the decoder. Then we have the task objective. What is our the task? Like we have the classification, regression, dimensionality reduction, clustering. So in the case of the task objective, they are the generative models. Their primary task is to generate the data. So core, look, GPT doesn't include only single LLM. It includes multiple LLM, different LLM for different things, different LLM for text, different LLM for the uh, video generation, different LLM for the image generation, different LLM for the audio generation. Basically, text is generated using the LLM. Basically, text is generated using the LLM. But like voice, images, and videos are generated using the different other models, like the diffusion model. Usually using the diffusion models. And videos can also generated using the models that generate the pixels in the time dimension. So we can have for that type of model for the video models. So overall they are the multi-model generation models. Means they have the multi-model, they have the multiple models, different models for different tasks. Okay, but if we talk about the core tasks of the text generation, or the text generation, they are the LLM based. So what the comparison we have done from A to D, that is basically based on the text for the text task. Remember this thing. So when we talk that they are the supervised, trained with the human feedback, uh, multi-shot learning has been done after the pre-training, and then the transfer learning is done. Uh, they are based on the transformer architecture with only the decoder architecture. So all that apply to basically the text generation model of the GPT or the Gemini. So next, either for doing the data analysis, either you must be familiar with the Python or you must be familiar with the R. But as Python is more general purpose than the R, nowadays we can also do the machine learning and deep learning in the R. There are the modules available, but not as much as what are available in the Python. Python can be executed on also on the GPUs, so that capability, what R lacks. Okay, but R is the language of the mathematicians. Basically, R works on the uh, vectors. In R, we don't have the variable type, a single variable type of a thing. Basically, we have the vectors. So it's a language of the mathematician. This is importantly for the statistical analysis. But Python, it is easy. It has more uh, end-to-end deployment pipelines. It has more modules in deep learning, natural language processing, even for the generative and the agentic AI are available in the Python. So for this program, we will be considering the Python only. We will be learning things in the Python only. Before coming to the practical part, let me introduce you what we will be covering. We will be covering the NumPy. We will be covering the matplotlib. Okay. So we will be covering the NumPy. We will be covering the pandas. We will be covering the matplotlib and the seaborn. Apart from that, we will be also looking for the handling the GPS data, how we can analyze and handle the GPS data, how we can plot the GPS data, how we can load the image, how we can analyze the image, how we can apply the image analysis operations. Then we will be also looking for the videos, how we can load the videos, how we can extract the frames from the videos, videos. First video is only the images that are continuously running. Like we have the 30 fps video, that is 30 frame per second, what is running through the screen. So we will be loading the data, we will be analyzing the video data. We will be also looking some modules of accelerating our data science course. We will be looking those modules from the NVIDIA has developed some modules that is capable of executing your code on the GPU, which accelerate your code thousand of time faster than normally running on the CPU. Steps. I will be providing with you the complete documentation how you can install the Python properly. Most important thing to make Python work is that you must install on the Visual Studio, Visual C++ Redistributable, all these supported packages. So that's the important point. If you are using the Windows, for the Windows user, please install all these redistributable C++ version. Okay, so install all till last one. Even it says okay that is the end of the support, but that also 5 is the end of the support plus, but please install all these which are available here before installing the Python. That is highly recommended. Just a second, Microsoft. And another thing what I want that for Python to work properly, this is the one thing. Another thing is that mm, skill learn, just give me a second. Installing Scikit-learn. Oops, wrong click. Installing Scikit-learn. Here is the way what we require. Initially there was the Scikit-learn machine learning in the Python. Okay, that image is not available basically. Yeah, this one image, it's important one. So you have to basically you have to install the build tool installer for the Visual Studio. Okay, that is what you have to do. You have to install the build tool for the Visual Studio. It's a direct download link. We just cancel out it. I don't want it. Okay, you have to install the build studio installer. Then after installing the build studio installer, you have to just install the development packages for the C++, as Python itself is written in the C++ core of the Python. So that's why you require the build tools for the C++, and that installation will be of 3 to 4 GB. After installing both these things on the Windows, you will never face any difficulty while installing the most of the packages. Another packages basically which for which the people face the difficulty is the OSM and NX packages. For that you have to install the GDAL. If you have properly installed the GDAL exe, everything will be working fine, and you have to set that as the path. Okay, so each and every packages of the Python can be installed without using the third party thing like the Anaconda and all. Okay, so this is the link I am providing to the link, how to set up the dedicated dependencies here. And okay, this one is copy paste. And the second thing, this is the image, what you have to follow. Image. If you have done this all properly, there will be no issues while installing any. Most of the packages will work. You will be never requiring the conda until the TensorFlow or the PyTorch or any of that. Okay, so if you have any other query, you can ask, and we will be working in the collab because we will be requiring in future the GPU. Okay, for the GPU, you have to do the GPU setup. Apart from that, when we will be working with the generative AI and the agentic, in that case also, if you are not using the API, Gemini or the GPT API, you will be requiring a lot of computation. So for that's why I highly recommend to work in the collab. So those who are not familiar with the collab, they can just say Google Colab. They can just search for the Google Colab and click on the this collab.research.google.com. This link. It might be very first or might down at the bottom somewhere. Okay. Okay. I have to click on the link for the copy and paste. So this is the what work with the Visual Studio Code. Yeah, things work with the Visual Studio Code. There is no issue. Python also work with the Visual Studio Code. You have to make the setup in the Visual Studio Code. It will be working fine. But again, if you are going with the deep learning or the generative AI models, you cannot work them with locally, because usually they required the 16 GB GPU RAM, not your CPU RAM, GPU RAM. They required the GPU that has itself the 16 GB RAM plus a minimum 32 GB, more than 32 GB, basically the system RAM. They required extremely large configuration systems when we are working with the LLMs. And even nowadays, the deep learning also basically cannot work less than the 12 GB RAM GPU. So your system must have at least 32 GB RAM plus the CPU must have the 12 GB of the RAM. This is highly required. So for this reason, I am preferring the Google Colab. Look, it's also economically beneficial. So basically, the systems we buy, or the system configuration what we required for the AI, that might cost around more than 2.5 to 3 lakhs. And what is the cost of the GPU monthly subscription? That is of only $10, which is equals to 1100 in 1100 Indian rupees. So if you look that 3 lakh and here only the 1100 Indian rupees, and that too uh, we are getting the upgradation as the new GPU comes in the market, we get the upgradation. As the new GPU comes in the market, we get the upgradation. So we don't have to worry about the even the upgrading after our system, because normal system will be degraded between 2 to 3 years in these days. So if you buy 2 to 3 lakh system and that will be degrading in the 2 to 3 years, that is not cost effective. Whereas on the collab, that things are cost effective because we are getting only an 1100. If you compare, if you buy only a 1 lakh rupee compared with a 1 lakh rupee system and this collab subscription, it can worth up to the 90 month the same thing. So economically, I find that thing more beneficial. Okay, until and unless if you are not doing any defense related work, collab is good. You can go with that. So I think my screen is visible to you all. Just give me a second. It's fine. I can just share that one because I need to let in the people. So here, if you are getting pop-up like this, you can click on the new notebook. If you are not getting pop-up like this, you can just either use this header toggle, or if it is already down, then you can see here the file menu. Okay, if you are not seeing the file menu, click on this toggle option. Okay, click on the file menu. After clicking on the file menu, you can click on the new notebook in drive. So whatever you do here, that will be automatically saved on your Google Drive. There will be a new folder which will be created with the name of the Google Collab, like this, with the yellow folder color icon. So inside this, all the notebook what you will be making will be automatically saved. Or work what we will be doing, that will be automatically saved. So let's click on the file, click on the new notebook in the drive. This will create a new notebook in my Google Drive. Now here you can just rename your file. You can just say whatever name you want. Okay, just click on it, name whatever name you want, whatever name you want. Just name it. And when the all changes are saved, you will be getting a tick here inside some small cloud icon, which denotes all changes done by you has been saved. Like this, it's currently saving the things. Now all changes are saved. So we have the file menu, which controls the file related options, like opening a notebook, saving this notebook, downloading this notebook, saving it in drive, GitHub, whatever things related to notebook. Or you can also download the notebook as the IPYNB, which is the extension for the notebooks, which is stand for interactive. I stand for interactive, PY stand for Python. Interactive Python notebooks, N for note, B for books. So interactive Python notebook, full form of this initials, or you can also download it as just as the Python file. Then we have the edit option to do, redo, undo, redo, to select a cell, to cut a cell, to add a cell, to remove a cell, things like that. And more important option, the notebook settings. From here you can set up the notebook, like you can select the GPU environment, you can select the CPU environment, you can select the TPU environment. So tensor processing unit, which is 2 times faster than the fastest GPU. Now GPU also have the tensor cores. If you are looking for the latest GPU, they have a new thing which is called tensor cores.
Like CPU do the scalar processing, scalar process. It's like if we are multiplying a two number, let's assume if you have a single core CPU, and if you are multiplying the two numbers, you can multiply, do a one multiplication at a time. So that is the scalar operation we can do on the CPU. Then GPU can do the vector operation, means multiplying two array at a single time. Within a single time, like you have the 32 by 32 two arrays, you can multiply within a single execution instance. So they can do multiple processing. That also depend on the number of the GPU cores. GPU has the light weighted thousands of code, light weighted task like normal simple multiplication, division, that type of a thing. Because GPU is not a general purpose device, CPU is a general purpose device. It can even run, you can even run a video game, or you can even run a video, you can even run images, you can run the Microsoft Office's tool, or you can run a simple C language, Python language, any of the code. So CPU is the general purpose device, while GPU is the not the general purpose design, which is basically built for the graphics. But thanks to NVIDIA has developed something which is called CUDA. Using that CUDA, we can put our Python code on the GPU and made them thousands of times faster. So the same code which is taking an hour of the execution on the CPU, that can be executed within the few seconds on the GPU. That's the power of the GPU. But small operation, small multiplication, elementary operation. Elementary, what does I mean by the elementary? Element-wise operations. Like first has to be multiplied by the first value in the matrices, has to be multiplied by first value. Second by the second value, and so on. Then when we talk about the TPU, which stands for the tensor processing units, which has been developed by the Google, they are twice as faster than the GPUs, because they do the operation in the 3 dimension. Like if we have the two 3D array, they can multiply both together at a single click. Like they have the 3D processing unit. They are processing in the 3 dimension. GPU process in the 2 dimension. Height, like we have the 2D array, and CPU process as the scalar. So as we why name the tensor processing unit? Because what we say, the tensors are the physical quantities that are the that are the force on the scalar usually, or that are the force in multi dimensions, or basically what why we call the vectors vectors or tensors. Look, scalar, you all are familiar with the physics scalar word. The scalar which has only the magnitude. Okay, so they are the only the numbers. Then when we talk about the vectors, vector means magnitude with direction. But if you that's for the physicist. But if you go for the mathematician and ask mathematician what is the vector, he will be answering a 2D array. So 2D array is the vector from them, because physics vector is usually represented by the mathematics 2D vector. Then tensor, tensor for a mathematician represented by the 3D or more uh, dimensional array. That depend upon the how many dimensions, or the how many dimension are used to represent that. Like we have the multi-dimension theories, like we have these string theory which represent the things into the 10 dimension, M theory which represent the things into the 11 dimension. So that's a different topic, we are not going for that. But basically tensor means array in 3D or more. So that's why we have the name TensorFlow, the deep learning library. TensorFlow, the flow of 3D or higher dimension vector through your model. So that's why TensorFlow. So so these are the processing unit what we have. Apart from that, you can not this one. Apart from that, you cannot only execute the Python here, you can also execute the R and Julia on the Google Colab. Google Colab also give the support from that. Apart from that, from here you can also go to the 2025 different versions, previous versions. But for this course, we will be using the latest one. Now, just let me adjust my screen. Okay, now next we are the view. V is used to control the view, like showing or hiding of the code. Then we have the insert to add code or text cell. Code cell where you do the coding. And text shell where you can write your things like the notes. Like for an example, if I take my mouse pointer and move it to the center of this, so we have the code and the text shell. If I click on the code shell, it will be generating a new code shell above or below it. So if I click below, it will be generating below it. If I click on the above, it will be generating above it. So like if I click on the text shell, that is like the notes for us. Or we can also use the HTML code here, like single hash for the heading, double hash for the subheading, triple hash for subheading. And there are various text formatting options also. You can also add the images here, so you can represent complete this collab as a presentation. You can include the links, you can include the images and all. So you can use complete collab as in uh, presentation or the PPT file. Then we have the runtime to either run all the shells, run before the focused cell. So if I have the multiple shell like this, I can just, this is my focus cell. So I can say run before, run after, run below, this type of a thing. Then we also have the two important option: restart session. Currently my session is not connected. Restart session will clear your RAM variables. Okay, it's like whatever you have imported or whatever you have variable you have defined here, all will be removed. It's like clearing our RAM. Then we have the restart and run all. Okay, restart and run all the shells. Then we have disconnect and delete runtime. This will clear both the RAM and ROM of the cloud environment. So when we click on this connect, we will be connected to a Google runtime. So once you disconnect from the Google runtime, your all variables, uh, either it is a RAM or it is a ROM, that will be deleted. So if you have large files, you can upload that on your Google Drive and you can link the Google Drive here. Okay, let's first me click on the connect. Just click on the connect. This will allot you a runtime. So now you can see here the runtime is allotted. Python backend GPU runtime is allotted. Normal runtime is allotted, not GPU one, and which has the 12 GB of RAM. You can see here I have the 12 GB of RAM, and you will be getting the 100 GB of ROM. Now I was telling you, if you have the large files, so you can upload on the drive. So here you can see the file options, files options. If you click on this file option, you can see here the option for mounting the drive. Once you click on it, it will ask you for the permission, whether you allow your Google Drive to mount the current file or not. If you click on this, the Google your drive will be mounted to this file only for you. It's not like if you share this file with some another person. In that case, that person will not able to access your drive. Okay, because it is connected to the uh, currently users Google Drive, where you can see here I have my account. So which whomsoever here account is mentioned to to that person's only basically Google Drive is mounted by default. Okay, and if you have the multiple uh, Google account sign in, then you can select while mounting the drive. Then we have some sample data. Okay, you can also upload your data. There is an upload option. You can click on this upload, but after the runtime disconnected, your file will be deleted. That's only the warning what it is saying us. If the runtime is terminated, your all files will be deleted. So that's the warning. So that is the basic introduction of the collab. Now let's start with the NumPy. I will be starting with importing the NumPy. So import NumPy as NP, which I usually like to call as the numerical Python, which is basically used to do the all the numerical analysis in the Python. So just either you can click on this play button to run the code written in this shell, or you can use the shift and enter. Okay, control and enter will be also executing this shell, but shift and enter will execute this shell and automatically create a new shell below it. Okay, if I use shift and enter, I am using shift and enter, you can see here automatically new shell is created below it. Okay, but executing non-empty shell will not create a new shell. Remember this thing. Now let's start with making a 1D array. So let's say array 1D, and now we can see np dot array. Now inside the array we required an object, a trivial object, basically list or a tuple. So let's pass a list of some numbers like 3 4 5 1 9. So this is the list of integers. Basically list in the Python is heterotype. You can have any Python object inside the list. Any Python object can be the element of the list. Remember this thing, any Python object, and all are the object only in the Python because it's the object oriented language. So just see the type of the object. What type of object is 1D array? So we can say type of object returned. So array, I can type of so we have here numpy.nd array. So it's NumPy, the module name, and D stand for n-dimensional array. It can be 1D, 2D, 3D, so n-dimensional array. So this is NumPy's n-dimensional array. Now on the NumPy array, we have some special built-in method which usually not available in the list. And remember, just like because NumPy itself is written in the C++. Okay, it's written in the C++ because Python lists are extremely slow, extremely slow. That is the main drawback of the Python. Python itself is extremely slow in the comparison of the other compiler-based languages. It's entrepreneur-based languages. Usually entrepreneur-based languages are slow, and Python in relevance to C++, it's extremely slow. So to speed up the Python, because when we are doing the deep learning or the other machine learning processes, we have the huge amount of data, and working with the huge amount of data with the slow language will be a very painful task. So they have integrated the NumPy, which stored your data as a C++ array. So inside the memory, this is stored as at the backend as the C++ array. So let's see the first, see the shape of the array. Okay, before, let's see the data type, data content, that is the more correct word. So we can say array 1D, yeah, dot d type. So there is a huge difference between this and this. This tells what is the content inside the array, and this tells what is this, what type of object is this. Like we have the list. So list is the list class object. And what type, basically list are the heterogeneous, they can have anything, but what type of data is contained inside the, like inside the array or inside the list, that basically that's not applicable on the list, but basically what type of data is it. Because when if you are familiar with the C or C++, their arrays are homogeneous. We define the type of the array, declare the type of the array, not define, declare the type of the array. So either they can be integer or the double or the long type of the thing. So here also the array can be of single type, like here it is of int type. So the data content, d type means what data does this array contain, that is of int type. Int 64-bit. Why it's represented at 64-bit in that way? Because in C++ usually there is no something like data type, like long, float, double, int, depends upon the size of the data. So what is the size of the data? What the amount of RAM it is consuming, based on that we define the type of the data. It's like you have a family and you are going to buy a home from that for them. So depending upon the size of your family, you will decide the size of the home or the house or whatever what you want to buy. If you have a small family, 1 BHK is okay. If you have this larger family, 2 BHK is okay. So that type of a thing. Same with the C++. So what is the size of the data that has to be stored? C++ or C defined the type. Like long has the different size, double has the different size, int has the different size. Okay, so that is the thing. Here we have the int 64-bit, because in Python we only have the int and float and type for the numerical, int float complex type for the numerical. So that has to be converted into C++ type. So that's why in the NumPy we have the int 8-bit, 16-bit, 32-bit, 64-bit. Similarly, float 16-bit, 32-bit, 64-bit type. Okay, so that's why there is the data type like this. Next, let's say print shape of the array. So array 1D, 1D dot shape. Shape means number of values along the each axis. Like if we are having the height and the column, row and the columns. So how many rows are there? How many columns are there? If your array is 3D, so like in that case, it will be number of arrays. Then how many rows each array have? How many columns each array have? So like if we have the two in 3D, we have the two array in one single array, and each array has 4 row, 4 columns. So it will be like 2 comma 4 comma 4. So in this way, the shape represent the number of element along the each axis. Here it is a 1D array, so it will represent the uh, element along the single axis or the last axis. In this case we have the 5 elements, so the output of this will be 5, 5, but that will be a tuple of single value. The shape will be always returning a tuple. The output of the shape always will be a tuple. So here a single value tuple which will be containing the 5. Next we have the size. Size is the total number of element in an array. How many total number of elements are there in the array? As we know, for a 2D array which contains the row and the column, the total number of array elements in an array will be the product of both row into column. In 3D, the number of matrices multiplied by the number of columns. Okay. So this is how size is calculated. So the number of elements cannot be in the decimal form. So here also it will be an integer. Going for the next, we can also do the statistical analysis on the array, like the mean, median, mean, standard deviation, variance. So min, max. If we want the minimum value in the array, so we can simply say array 1D dot minimum. If we want the maximum value in the array, we can say dot max. Then if we have to calculate the mean, you can say array dot mean 1D array. For standard deviation, we can say dot std. Now next, if we have to calculate the variance of array, we can say array array by again array 1D dot var. So by using these different statistical analysis calculation, you can calculate the mean, standard deviation and the variance. So I want you try out all these running things side by side. As previously I have told you, all the values inside this array are the integer. But what will happen if we have any float type array? Sorry, any float type element, like if we have 5.1, so only this element is float type, rest of them are the integer type. One thing I forgot here, also print the array. Array. So it will convert all the values into the float, because without the loss of values, without the numerical loss of the value, numerical with the loss of the value, all integer type can be converted to a float type. But the float type, all the float type numbers, the floating point numbers cannot be converted to one type. There might be a value loss. So to prevent the value loss, it convert into a higher dimension. Like if we have any complex number, here all are the integer. If we have a single complex number like 9j, it will convert all to a complex type. So NumPy will be handling all this automatically, this conversion. And you can also give your complex type. If you don't want, in this case it will be a float 64 type like this. If you want to define your own type, not own totally custom type, but from the anything from the predefined type, you can say d type equals to, I want it as float 16 bit. So you can pass that as a string. Now this will be a float 16 bit. So this is how you can control the output type of the array, output data type of the array. If you have any doubt, query, question, you can just text in a chat box, Zoom chat box, or you can just unmute yourself and ask your query. Now I will be moving forward to the 2D array, two-dimensional array. Let's build the 2D array. Build a 2D array, I can define a variable array 2D. So array 2D equals to np dot array, again built in an array from the list. Again I have the list which contains the three list of equal sizes. So each of this list represent the row. So this will be first row, this will be second row, this will be third row. Moreover, for better understanding, I can write down like this. So first row, first column, first row, second column, first row, third column. Again, second row, first column, second row, third column, second row, second column, third column. Then last row, first column, last row, second column, last row, third column. And I want them, I can say here D type, I want them as int 8-bit, or I can say unsigned int 8-bit. That's more better. As all the operation what we have applied previously on the 1D array, we can also apply it on the 2D array. Just need to change the next line. This is an output where we have the 2D array and the type of the array, that is again the NumPy ND array, n dimensional array in the NumPy. Now we can also calculate array in the shape. Always remember first row then column. Always remember this thing. First thing will be the row, second thing will be the column in this. Then we have a size total elements, 3 into 3, that will be 9. have to replace 1D with the 2D. Then the minimum, maximum, mean, standard deviation, variance, most of which you can execute just by changing the variable name. But here I want to tell you one more important point. Let me first execute this thing. So you can see the shape will 3 comma 3, 3 rows, 3 columns. Size is total number of elements, 3 into 3, this is 9. Then the maximum element, minimum element, mean, standard deviation, variance, all that. But for an example, if I want the minimum value along each row, minimum value along each row of array. So for that I can pass here something in the function, that is the axis. I can say axis equals to 1. So that is the minimum value along the each row. So in first row you can see minimum value is 1, in the second row minimum value is 4, in the third row minimum value is 7. Similarly, you can also calculate the maximum, min, standard deviation, variance along the row or the column. For the column, so if somebody asks what is the maximum value along the each column, so column we will be using axis equals to 0. So how axis index is defined? Basically axis index is defined based on the shape. When you say okay, one single shell, when you say array, so shape, so whatever will be the output of the shape, you start indexing from right to left, reverse order, from here to here in this order. So this will be at the 0 axis, this will be at the 1 axis. So this is the row, this is the column. So row, column is at the 0 axis and row is at the 1 axis. So not from the left to right, but right to left, reverse order. And we have another one, third dimension here. So in that case, the third dimension will be the axis 3. So innermost axis is the 0 axis and the outermost axis is the 1 minus the total number of the dimension. So this is how you can identify the axis of the dimension in the multi-dimension array. These arrays are extremely fast than the loop, extremely fast. If we take an example of operation between the operation that has to be some done on the list, same operation if we try to do on the array, what is the difference between the execution time, which basically called the time profiling. Let's take a big list. I will be making by using the range method. Range, I can pass the 10,000. So it will generate number from 0 to 999. And to convert from the range object back to list, I can just typecast this into the list. Now I'll have a big list. Now, for an example, I have to find the square of each and every number. So I will be using here the list comprehension, which is the most optimizing way of doing this. You can say for number in big list, it will be taking a one by one each and every number. I can say now number star star 2. That is the raised to the power 2 stochastic 2. That is the power symbol. So it will be taking one by one each number from this list and then squaring each and every number. So this will be containing squares of the number. Now to calculate the execution time, we will be adding the magic functions in the collab, the special functions that are only available in the collab, which is percentile time it. What time it will do? Time it will execute this code multiple times based on the execution time of the very first execution. So if it is taking a large execution time, it will execute like 10 to 15 times only. If it's taking very less execution time, then in that case it can run up to the thousands of time, the DB code. To find the mean execution time and the standard deviation of the execution time. So let's execute this thing and let us see how much time the list is taking for this execution. So you can see here it's taking 600 microsecond with the standard deviation of 173 microsecond plus minus of 173 microseconds. So it has executed this function 1000 times and use the best time for calculating the mean and the standard deviation. Next, we can convert this to a big list to a array. You can say big array equals to np dot array of big list. So now we have built an array from this list. Uh, Now in the case of the array, because in the case of the list we cannot apply the operator, numerical operator directly, but on the arrays, as arrays are of homogeneous type, we can apply the numerical operator directly. So we will be applying the power operator star star 2, which will square up each and every value inside the array. This will square up each and every value inside the array. This is an elementary operation, element wise operation. This operation will be applied to each and every element in this array. And actually storing is not required. We are only calculating the execution time, but okay, we can say squares because we don't need these variables. So I am okay. Let's use the another variable for preventing the confusion. Percentile time. Let us see how much time the array took for the same execution process, and you can see 100 times less than the loops. So arrays are 100 times faster than the Python list. So in Python, basically list and the loops are the things which makes Python special. extremely slow, and we can calculate the average of this logically more than 100 times fast. Just a second. I'm coming to your query. Just give me mm, yeah. Uh, above also we have the numbers cluster tool, which is the element wise. What is the difference? On the list, we cannot directly apply. We cannot say in the case of the list, like this is a list. I cannot say list star two. Okay, I cannot directly apply the power operator or whatever operator like plus two on the list, in the list and the other numerical value. That is the thing. Whereas in the case of the array, we can directly apply the numerical operator like this, every value of the array. But here we cannot apply. This will loop through each and every value. This will be taking each and every value. Then after taking the each and every value, it will be applying to each and every value. Both each and every value. In this also we are squaring each and every value. In this also we are squaring each and every value. But for in the case of the list, we required loop for applying the mathematical operators. But here we don't require the loop for applying the mathematical operator. That can be done directly. Let's take an example of this array. Like we have this 2D array, which is initially look something like this. So I can say plus 2. So when I say plus 2, 2 will be added to each and every value of this array. So this is called, what does I mean by the element wise operation. But if it will be a list, then we have to use the uh, nested loop to add 2 to each and every element. And that is the main thing which makes it extremely slow. Any other query from anyone else? Yes. So thank you all very much. But before ending the session, let me share you the link for it. Okay, two important thing. CS231N. I am for this tutorial, for this NumPy tutorial and the matplotlib tutorial. I'll be referencing the Stanford deep learning program Python tutorial, and I also have the collab file for that with proper in-depth documentation, so you don't have to worry something you are not able to do. You can go through that and ask the thing again. Don't know what is the issue is going. You can get the video. All the sessions are recorded. Don't worry about that. All the sessions are recorded. You can just type a message into a group link. I request you highly to add this data science link to your drive. You can add that as the shortcut to your drive. Okay, please add this as the shortcut to your drive. So whenever you require these files, they are available to you. The adding shortcut will not